So I'll show you, I did not make a presentation for this because it's shorter, let's say. But we'll discuss a little about ORMs and JPA. So this is something that is used a lot in the industry. I, as architect, disagree completely with ORMs, but you have to learn them because 90% of Java projects use Hibernate. So here we are learning about it. So what is the ORM? Object Relational Mapper. Basically, it maps between objects in memory, so objects which you designed hopefully using object-oriented paradigms, and database tables. So if we think about it, right, at a relational level, there are some differences or there are some missing concepts or different concepts than in the object world. In the relational world, you have tables which have entries, you have foreign keys, you don't really have inheritance, you don't really have composition, although you could do something to emulate it. Whereas in memory or in the Java world, you have objects, you have polymorphism and inheritance and so on. So you have different concepts and we want to somehow map them, or some of them at least. So then about 15, 20 years ago, some developers thought about this idea. What if we have a component, a logic component, which maps between our in-memory model and our relational model? So basically, at the very simplest level, each database table is a class, each column is an attribute of that class, and there are some lifecycle methods which would map between finds and inserts and so on. So basically, such a library, let's say, or such a logic exists in most programming languages which are mainstream. So there are ORMs for Java, Node.js, .NET, you name it. Ruby, I think, has one. So basically, it's inevitable that you'll have to work at some level with one of them. They usually simplify your life because the purpose was that you would work with objects and behind the scenes, the ORM would do inserts and selects and so on, and you don't have to care about it. In reality, and that's why I don't like it, actually, you do have to care some 20% of the time what you're doing, because if not, you get exceptions and problems down the line. Okay, so I will show you the very basics of using object relational mappers, and you will have to learn a little on your own, I guess. Depends on how complicated you want to make your life. So concretely in Java, Oracle, I think, or Sun, not sure, defined the API, the specification, which they did not implement. So basically, they just defined some interfaces and said, okay, somebody else implement the ORM. We just define the interfaces that the ORM should implement. And these interfaces collectively are called JPA, the Java Persistence API. So it's a set of interfaces and base classes which ORMs should implement. And in Java, we have two big ORMs and a million small stupid ones. The two big ones are Hibernate, which we will use, which, by the way, one of the main contributors is a Romanian guy from Cluj, and Eclipse Link, which was built by the team which also built Eclipse, but we will not use it. Okay, so the good thing with this, or the purpose of this JPA, is that you could swap, theoretically at least, the implementation of JPA, so Hibernate or Eclipse Link, you could swap them and replace them without having any impact really on your app. Actually, in real life, this does not happen because there are some small edge cases in which the Hibernate is a little different than Eclipse Link, and then you cannot really replace them, but in theory, it could work. Okay, so we'll talk about Hibernate really. But just for you to know, we will only rely on JPA and we could swap theoretically Hibernate for Eclipse Link. Okay, so in the simplest case, we just have one object. And this is the use case in which you will use it a lot of times at least, that you have one object that is mapped to one row in the database, and you want to handle it somehow, or you want the framework to do some stuff for you. The framework basically has 4 states in which your object can be in. And based on that, the behavior of the framework will be in a way or another we will discuss right now. So basically, in the simplest case, let's say that you do a find. You say, okay, find me a student with ID 1. This would return an object, an instance that the framework, that Hibernate will create. So you will not create a new student. Hibernate will do it for you and will populate the student fields with the values from the database. So behind the scenes, it will do a select. It will take the data, it will map it to Java data types, so to integers, big decimals, and so on, dates or whatever. And it will return to you the instance. That instance will be managed, at least for the duration of a session, which right now we can just consider it a transaction. So for the duration of that transaction, the instance will be managed. What does this mean? It means that if I call a setter on this instance, this will issue an update at some point. So Hibernate will handle for us updating the state in the database based on what setters we are calling. Right? And updates usually are called when you call this flush method, which is called by default by Hibernate when the transaction ends. Actually, when the session ends, but in our case, they are overlapped. Okay, so this is the state in which you receive instances from the database. Well, we want also to be able to create new students. So you can, because the entity objects are podros, will be simple podros as we discussed last time, you can just instantiate your student class, fill in some data, and then pass it to Hibernate to persist it. Basically, Hibernate will do an insert then, and will save it in the database, and then we'll track it. So it will enter this managed state, in which if you then call some setters, it will do update statements for you on the database. Okay, there is also a removed state. So if you have a managed object, something that you have on the database, and you want to delete it, you just say remove, and then when it flushes, it will delete it from the database. And there is another state in which, let's say that you instantiate a student by hand, but you also set its ID to an ID that you know that exists. So you inspect the database somehow else, and you see that there is a student with ID 1, and say, okay, I want to update this student without really having to first find it, to do a find, and then to do a set on it, and so on. You can just instantiate a new student class, set that ID, set the values, and then do a merge operation, which basically will merge your transient or detached entity in this case with the managed one, and will create, basically, it will bring it in a managed state in which then you can do setters and so on. So these are the 4 states in which entities can reside, and you really are interested only in the transient, because this is before you do any kind of persisting. This is usual Java. In managed, you'll be interested because you'll do set whatever text on the question, for example, and then an update will be created for you, and removed just to delete it. For detached, I think for now you will not really be interested in it, but we will see. Okay, and then the question is, how do we actually tell Hibernate, okay, this class corresponds to this table and this attribute to this column and so on? There are 2 ways. Old way, which is with XMLs, which we will not use, so forget about it. And the newer way with annotations. So you just annotate the class with an entity annotation. You can then annotate it with a table annotation and say, okay, this is the name of the table. You can annotate fields with @column annotation, so column annotation, and you can specify the name of the column and so on. Right, so pretty simple. Now, related to queries, so if you want to retrieve more entities from the database, you have 3 options. What I forgot to say is that Hibernate and usually ORMs have another good advantage, that they are database agnostic, meaning that they perform these operations without depending on a concrete database. How do they do this? They detect which database you are using and use a different SQL dialect for each of them. we will see when we will start the example application in the next hour. The first thing that Hibernate will say, it will say something like detected dialect Postgre or H2 or MySQL or whatever, what database we are using. And based on that, it will generate slightly different SQL just to match that particular database. Okay? So we have to build queries. We have two good ways and a not so good way. One is to use a dedicated SQL-like language, which is this JPQL. JPQL stands for Java Persistence Query Language, I think, which we will not use because I don't want you to learn a new SQL just to do some queries. Instead, we can use the criteria builder, which is like a builder pattern for building SQL. So you have a class, a query class, which has a from method, which has a where method, and so on. So like building SQL, but in Java code. And the last one is native, which is basically JDBC. So Hibernate can execute for you JDBC, but then you're no longer database independent, because in JDBC you write SQL that works for your database, might not work for a different database. For example, Oracle has some very specific syntax in inserts that you could not use in other databases. Okay, and the last point that I would want to do, and then 5 minutes break, would be that because we have all this information about tables, columns, types, and so on, Hibernate can also generate for you the schema. So Hibernate can generate the schema, meaning the tables, the foreign keys, and everything from the entity classes. And it can generate it by, you can configure this generation by setting this property. Actually in Spring, there is also Spring in front, but it doesn't matter. And you can set it to the following values. None is Hibernate should not do anything. The schema is already there, and it does not have to create any tables or anything. Then there is create only, which at the start of your application will issue create tables for each of your tables, and then alter tables for the foreign keys and so on. Then drop is at the end of your application, or at the beginning, not sure, I think at the end. There will be drop statements for your tables. So there will be a drop table student, drop table, blah, blah, which will be executed to clean your database. This is usually done for tests. If you run some kind of test on your database, at the end you want to clean it. Then there is the create, which actually at the beginning it does a drop just to clear whatever old stuff you have, and then does create statements. Then there is a create drop, which does drop followed by create followed by a drop at the end of your application. So they are just combinations. But what I would recommend you to use, because if you use Flyway, like we discussed last time, use the validate one just to check that the thing that you already created on the database matches what Hibernate expects from you. Because if there is a mismatch, Hibernate will not work correctly. If you have a differently named table or column or anything like this, it will detect it and tell you, okay, I did not find a text column on your question. And then you have to correct the code. Okay, and update is a stupid idea. If you use Flyway, that's the way to go, not with updates from Hibernate. And if you will not use Flyway, I would recommend you to use create only or create drop, or maybe create one of these. So to create it for you and optionally drop it at the beginning. Okay, so that's the very high level intro of ORMs. Any questions until now?
The drop instruction clears the tables?
The drop instruction deletes the tables. So with create, you create the table. With drop, you delete it, including all the data in it. So, yes, you need them. These exist usually for tests, or for local development, but not for production. So for production, this would be a disaster. But for local development, it's useful because then you don't need to care that you have to do alter table to add a new column. You just drop everything and recreate it. It's like, doing a nuclear option. You delete everything and then you create it again just to be sure that it's consistent.
So after we do our test, we should jump them always?
I mean, in our case, is not. But usually in the industry, that's how it's done, just to keep the database in a clean state. Because if not, let's say that you have one big test database and several projects use it, what would happen is everybody's creating tables, and maybe there is also a schema created for each test or something like this, or for each test suite. And then you have a lot of tables that are there and nobody is using. So that's why you create them at the beginning and drop them at the end. And this option which does drop, create, and then drop at the end is just that if you have older tests which ran before, which failed, did not clear the database, you want first to drop everything and create it just to be in the consistent state, and then at the end to drop it just to keep your room clean at the end. So that's the purpose. But for real life scenarios, you will never use this. You will use Flyway instead for managing the structure of the database. But here is something that I heard from the room, that you could theoretically use this to create your Flyway script initially. So if you're a lazy person like me, this is how I do it. Most of the time I create entities and then I look in the console, for example, and see what creates table statements it generated for me. I just copy paste them, adjust them a little to be nicer, and that's it. So this could be a way to create your database schema. Okay. Let me delete what I did with the other guys first. Actually, let me let this one in. Okay, so I created a small project just so we have it and to not waste time. We have some entities and let's discuss a little on them. We have a student, so a normal Podro. If we look, we have here from Lombok the data annotation. The toString annotation again is from Lombok. It just creates a toString method which contains these fields or concatenates these fields into a value. And then we have entity annotation. This is a mandatory annotation from JPA. All classes which are entities, so which are paired with a database table, should have this entity annotation, right? So this is the first thing that you should do. You should annotate your classes with entity for the ones that you want to persist on the database. Okay, then I have an ID. All JPA entities must have an ID. You could have a composite ID or a composite primary key. In that case, you need to create a key class which can contain both of them. Why? If we look again in this diagram, you'll see that we have, for example, a find method, which you have to pass an entity class and the primary key. The primary key is one value. If you have a primary key which is composite, this one value, this one Podro, must contain both or all three fields, right? Just because there is one parameter. Okay, good. Then we say that this is a generated value. This means that Hibernate, or JPA in general, will expect that the database, in this case the database because it is an identity, generates a value and passes it back to Hibernate for this field. It does not expect you to pass a value in this field, for inserts at least. Okay, then we have a name and a number. These are not annotated. By default, if you don't annotate a field, it is a column with this name, with the same name, with one big difference. Namely, if you have a camel case name, so you have my number with a big N, it would transform this into my underscore number on the database, because databases usually ignore the case for identifiers. So then it transforms camel case into low snake notation. Low snake means words separated by underscores. Okay, and then we have a list of grades. Grade is a different entity. So we have a one-to-many relationship. Why? Well, each student can have multiple grades, and each grade is assigned just to one student in the end. And this join column annotation basically says that it should create, or with this annotation, you would specify which columns to join in order to find the grades for a student, right? In our data model, most likely the grade will have a student ID column, and we want to pair the ID from the student with the student ID from the grade together. So usually here you would write these names, but because I was lazy, I did not write anything, and I allowed Hibernate to find some names for me. So it will generate some names by a default mechanism, and we can override these names if we want. Okay, and this fetch we will discuss later. Okay, then let's look at the grade. So it's the same data entity toString, entity again mandatory, ID with a generated value, some plain columns, and we have a many to one to a teacher, right? So I, as your teacher, can give you some grades, right? It's many to one because each grade was given by a single teacher, but a teacher may give multiple grades, right? And again, here a join column in which I allow Hibernate to define how the columns should be named. Okay, then let's look at the group. So a group, again, the same entity. And here I have a table annotation. This I use to force Hibernate to rename this table. Why did I do this? It has something to do with the name of the class.
It's an SQL keyword.
Exactly. Group is SQL keyword. Use it in this group by. And if I would try to create a table named group, it would die. It would say a syntax error that it makes no sense. So then I use this to rename this to class, which class is a Java keyword, but not a SQL keyword. Okay. Then I have ID, a name. I have a one-to-many to students. So again, pretty clear. A group has multiple students. And I have a many-to-many with the teachers. I will delete this. So many-to-many with the teachers. And in teacher, I have again, I will delete this. And this we will do later. I have a many-to-many to teacher in the groups. And here I can see it again defined here. The many-to-many generates a join table. So it will generate another table to connect the groups and the teachers together. This is done by Hibernate beneath the scenes. But with this annotation, you can specify what's the name in your database of this table, what are the columns, and so on, right? In your case, in which you already have the database schema, hopefully, because you already did the JDBC repositories, you will use the column annotation, which we'll see immediately, and this join table annotation, and so on, and the table annotations to give the names to match exactly the name that you used in your schema. So if you have a create table called teachers instead of teacher, here you would have to put a table with the name to be teachers, right? So this is just to be in sync with what you already created in Flyway, if you already did it. If not, you can use this to generate appropriate names. Okay, good, and that's more or less it. And here, in this class, I will show you this method is some boilerplate, which I will explain shortly, which you don't need to write because you will use Spring, and Spring will do this for you. So, as we discussed, you have the transactional annotation, which creates transactions, and you can create an entity manager, you can obtain an entity manager through injection. So you don't need to create it by yourself. But in vanilla JPA, you have an entity manager factory, so this class, which you could also create by hand, but here I just got it from Spring. And you create a so-called entity manager. This entity manager is responsible for keeping track of all your classes, all your instances that you have in a managed state. And it also has some basic transaction management and session management into it. So basically what I have to do is I have to create this entity manager, start a transaction, then I do here some code, which we will define ourselves, and then I commit at the end. And if I get the exception, I want to roll back. And I need to always close the entity manager because if not, I will have a memory leak, maybe. It depends, but it's a good chance that I'll have a memory leak. So all this stuff is handled by Spring. You don't need to do it. I just want to show you that this kind of ugly boilerplate you would need to do if you would not use Spring. Or a different framework which manages this for you, like E.
with this managed state or so basically when we create a new entity before we insert it,
Yes, it's a
and the
transient.
entity
Yes.
manager doesn't know about it.
Exactly.
Once we insert it, and if we do something on it after,
Yes.
it will automatically. So it's like an observer pattern.
Exactly.
So behind the scenes, it will do an observer pattern for us that we don't see.
So the exact way in which it detects dirty state, meaning that you called setters on your managed instances, I don't know for sure, but I would imagine that it's a little simpler than an observable pattern, but something like that. I think that it simply tracks, so it has a map with all the entities that you have, and I think it tracks somehow the state of the two. I think it just does a comparison at the end or something like this. But conceptually, that's the idea. If you call a setter, it will eventually do an update. It does not do it immediately. It does it maybe at the end of the transaction when you maybe call several setters. Right? Because if you do on the same student set name and also set, I don't know, the number of your ID, let's say, of your real life ID card, then you would not want for these two setter calls to generate two updates because there are two round trips to the database which could be compressed into one single update. So this Hibernate does behind the scenes. So you just call all your setters one after the other and it just creates one update. Okay?
And the other. So based on this, when we work with this entity manager,
Yeah.
The best practice would be if when we create a new object, get it in the entity, in the managed state as soon as possible, and then practically we don't have to do anything more.
Yes. Yes. So just for your to be as easy as possible for you, you should get the objects in the managed state as soon as possible and then work with them like that.
And then
But
we forget that it's managed and it's automatically.
yes, exactly. And then you can forget that it's managed. We will see immediately what caveats exist and why I don't like object relational mappers. Okay. And the last thing that I want to show you before we start writing some code is that here I specify this create option, meaning that it will create the tables and we will see it in the console. Also, here is some stuff that I would suggest you to copy paste in your application properties, which set some logging levels so you can see the SQLs that are created and what values are inside those SQLs. Right? So if you put this, you will see the SQL queries created by Hibernate. Okay, so let's just start the app without doing anything.
Eventually, before we forget, I had the question with the inheritance.
Yes, we will go to inheritance later when we are in the, let's say, free time. Right now, let's just focus on the simpler things. So if we look, I just ran it without any queries, without anything really. And because of this create, which also does a drop first, I can see that, okay, it did drop on all these tables. If they exist, then it did create tables. Lastly, it did alter tables and added foreign key constraints. It does it like this because then it's easier to manage. If you have a circular dependency with foreign keys between tables and so on, it's easier to do alter at the end. Okay, and this is basically what it does by default if I specify it to create the schema. Okay, then let's start doing some stuff. Let's insert a student. Right, I want to show you all the operations, how you can do them, just so that you, let's say, learn this. So here I just write some code and this is executed inside this transaction that I defined before. So here I obtain the entity manager actually from this. So let's say that I create a new student and I set the name to be whatever, so almost whatever. And I set the number to be A123. And then to really save it in the database and bring it to the managed state, I would say persist and and student. Right, so I'm persisting the student. Okay, and at the end, maybe let's just log it to see what the student has inside. Okay, I will run this. And by the way, I forgot to show you. So at the beginning, before all this stuff, the first thing that it says is it uses H2 dialect. H2 is a small database that I'm using just because it's faster to set up right now. Okay, so after all this create table, after this started playground, it did the insert into student, ID, name, number. It did not insert ID and it obtained it from the database. And it bound the first parameter to whatever, so the name, and the number to A123. And then what I obtained from the database is student with ID 1, name whatever, and number 123. Okay? So this is a simple insert which is created automatically for us by Hibernate, just because we call this persist method. Okay, let's also do a read. So after this, I run in a different transaction because I have a purpose here. We will see immediately. Okay, so I say here that I want to find a student with ID 1. Actually, here I could have just written this, whatever, it's more readable, I think, like this, because of the resolution. So the find method, you have to specify the class and the primary key. Right, the primary key, we already saw that it will insert with ID 1, because it drops the tables and recreates them, the IDs are reset on each time. Okay, and let's just log this. So I copy this and I log it. Okay, let's run it again. What do we see? We see that it did the insert that we had before, and then it did a select. So here, a select and with a where clause, where ID equals question mark, and it bound this parameter to the value 1, right? And then I obtained it. Now here, this is already in a non-managed state, it's in a detached state. Why? Because the transaction that in which we obtained it was closed, right? This run with entity manager closes the transaction at the end of the, and also the entity manager at the end of the method. Okay, so we are in a detached state. What will happen if I do something like this, which is other get grades to string? Yeah. Depends if I deleted the, yes, it died. Okay, why did it die? Well, here it says failed to lazily initialize the collection of roll grades, could not initialize proxy, no session. So there is no session, which again, you can conflate with a transaction for our purposes right now. Why did it happen? Well, the most naive way in which you could think was, okay, we have the student, which has grades. We also have a group of students, right? So it's a group which has multiple students which have multiple grades. You would say that the most naive way, if you load one group, is to load all the students of that group because it's a property in the group object. And then for each student, because each student has a property, which are the grades, you will also load the grades for each student, but also the grades have a teacher. So to bring it in a consistent state, you would also need to load the teacher. But then the teacher also has groups to which it's assigned. So you get back to 0. So basically, you would load probably the whole database just because you want to read one group. So what's the alternative? The alternative is that for any kind of relationships between tables, JPA defines a fetch strategy, when is this object fetched? Is it fetched eagerly? So when I load the parent entity, are also the children fetched in the same time? Or is it fetched on demand, lazily, when I need it? So for the grades, they are loaded lazily. Why? Simple. So here I have a one-to-many, and the fetch type for one-to-many is lazy by default. Meaning only when I try to access this property, it will be loaded from the database. Right? So how do I circumvent this problem? When one option would be to have a eager fetch. Meaning when I load the student, I also load the grades in the same time. If I run this now, it will not die, hopefully. It did not die. And what can we see? Okay, so it inserted, and then, yes, it's an empty list, sure. And it also, in the same select in which it selected the student, you can also see here that it also selected the grades in a single select. It did one join between the tables and selected everything in one go. Right, so this is an option, and another option is to load this inside the transaction. So when we are inside the transaction, to also load the children. Okay, what else? If we look here in the tables, we have a small problem in the created tables. Namely, we have a teacher groups table, which connects the teachers to the groups, but we also have a class teachers table. I think this is not what we wanted, right? We have two tables for the many-to-many relationships. Why? Because in the teacher, I have a many-to-many annotation, whereas in the group, I have another many-to-many. How should Spring, or how should Hibernate in this case, sorry, how should Hibernate know that they are the same relationship, right? For us, it's only one relationship at the model level. But how should JPA know it? Maybe they are actually two different relationships. So in order to inform it that it's a single relationship, here you have to say mappedBy, and you have to take the name of the property in the other class. So this teachers collection has already been mapped by this annotation from the groups. If I rerun this, I will only get one table. Right? This is very important. If you have bidirectional relationships, meaning in both classes which are involved in a relationship, you want to be able to access the other class, then one of them has to map the other relationship with this mappedBy. If not, you'll get two different relationships, two different foreign keys, because it cannot know that they are the same thing. Okay, so if we look in the SQL, it created grades, student, teacher groups, but no class teachers. Okay, we can also here in this join table, we can change the name. For example, instead of teacher groups, we could say my groups, or something like this as a table name. And it should work. Okay, right, create table teacher and create table my groups, right? So you can control the name of the table through this property, and you can, for example, change the name of a column with the column annotation. So you have a column annotation, and you specify the name of the column like this. So you can say full name, let's say, instead of the teacher name field. Okay, and if we look, for sure, if we look at the create table teacher ID and here full name, right? So basically this is how you can control all this stuff. Okay, so one last thing that I want to do in the live section of this class is I want to show you how to do a query. So again, I am running in a new transaction. and I want to use the criteria builder. So I get the builder from the entity manager. Then with this builder, I can create a query and I have to specify what's the return type. So I want to obtain a student or more students from this query. Then I will have to store it in a variable for sure. Okay, 1 second just to make it full screen. Okay, so I have the query. Then I want to select all the fields from the student class. So this is the syntax, select, and there you specify like this. And let's see, we get the students by doing like this, right? So I basically the query itself like this is translated somehow, let's say, and I obtain the result list from it. And let's just log it. And let's see what output we get. Okay. So here it created two selects because I have this fetch type which is eager, and I obtain more than one student, then they did not join the tables anymore, but did first select for all the students and then a select for the grades of all the students. And basically this is the select that I wrote. So it selected all the columns from the student table, right? And if you want to add where clauses and so on, you can just do query where, and here you can put predicates. And that's more or less it, right? So this is to build queries which are not simple selects. Okay, any questions related to the very basic stuff that I just showed you with the entity manager? Okay, so basically this is probably everything that you need to know, or most of the stuff that you need to know to do the assignment with Hibernate, right? I did not do a remove, but it's simply here there is also a remove method. The merge is to update or to force an update, let's say. And there is also a remove method to delete student, and that's it. So basically, you can think of the entity manager like a simple DAO or a more complicated DAO. Let's put it like this. Okay.
Outside the entity manager transaction, the the entities are still managed.
No.
So just
So-
in that block.
Exactly. So only in this block.
So if I change something, close the app, then it won't be persistent.
Exactly. So that's why you will annotate your service methods with the transactional. If you annotate your service methods with the transactional annotation, all the code that you write, all the business code that you write will be in a single transaction with a session, meaning that if you obtain from your repository things and you do set on it, it will generate update. Of course, then in the JDBC part, you'll have to do the update anyway. So that's why probably you need to call the save methods in any case. But using purely Hibernate, you would be safe to not do updates by hand. Okay, and just to show you how it can look like. So this is the example that I put on the GitHub. You can find it there. And for a repo, a simple CRUD repo, this is the example. So find all is exactly what we did before, also with students, exactly the same. The save method, I just did a persist or a merge, depending if it was already created or not. Remove is with remove, and find it's with this option of nullable, but what we used before, right? So this is your basic JPA repository. The good part is that you can easily parameterize or you can easily extract a base class. If you have 5 repos which do the same thing, just for different classes, you could easily extract the student class in a variable and use that and create a base class. Okay, and what I would strongly suggest is that in your factory, to obtain the entity manager directly from Spring through dependency injection, because then Spring will manage the lifecycle of this entity manager and close it and create it when needed, and to just pass this to your repository. So in the factory, if you do it like this, you're pretty safe, and Spring will handle for you the destroy operation and so on of the entity manager. Okay? Okay, and basically, as I showed you last time, in the service itself, if you annotate it with transactional, then you should not have any kind of lazy exceptions and so on if you do all your logic inside the method. Why? Because if it's transactional, then it allows, or there is an open entity manager session, and then you will not get exceptions because the queries will be run as there is a transaction. Okay? Good. Any questions? Okay, I take that as a no.